In this video, we are going to perform data visualization on a data set that we have downloaded from the Ministry of Health and Family Welfare. And so basically in this data set, as you can see over here, this data set displays us a few columns like the state name, the active cases in that particular state, the positive cases, the number of cured cases. So this is a data set which changes every day. And for now, as you can see, this data set was used on 12th January 2021. So whatever data you see below was used, and this data set basically belongs to 12th January 2021, and this data set will keep changing every day, and so you'll have to rerun this code again. But for now, this data set, as whatever you see over here, is as of 12th January 2021. And let us go ahead and use uh, libraries like matplotlib and seaborn, which will help us to visualize this data set. And before we begin, as you can see over here, these are all the imports over here. So we can see that I've used three imports over here. One is the pandas. We have imported pandas, and then we have imported seaborn, and in the end, our third import is the matplotlib. So when it comes to pandas, pandas is a Python library which will help us to create data structures, and pandas will also help us to manipulate these data structures. So the other thing is that we read the data set with the help of pandas. So as you can see over here, we use this code over here called as pd.read underscore JSON. So this is a JSON file. Usually we use CSV files, but over here it is a JSON file. So pandas will help us to read the dataset and work on this dataset, also help us to manipulate this particular dataset or any dataset. And the second import over here is the Seaborn. So Seaborn is a visualization library which will help us to visualize statistical graphs. So it is nothing but a visualization library which is based on matplotlib. And then over here, our third import is the matplotlib.pyplot, and we have imported this library as PLT. And what this import really does is that it is a plotting library, and it will help us create plots. All right. And as you can see over here, we have read the data set using the pandas again. So we have read this JSON file, and this is the link to the data. So using this, we have read the data set, and as I told you earlier, this data set is as of 12th January 2021. So every day this data gets updated. All right, and this is how the data set looks like. So this data set has columns like the state name, active cases, positive cases, cured, death cases, new active cases, new positive cases, new cured, new death, and in the end we have our state code. So we are not going to use any machine learning algorithm over here, and we are just going to visualize this data set. And so there are no independent and dependent columns over here, and we don't have any target column. So let us go ahead and understand this data. And as you can see over here, we have started with the data understanding part, and the first function that we have used over here is the df.shape. So what this df.shape shows us is that it displays us the total number of rows and total number of columns present in that particular data set. So as you can see over here, our data set has 37 rows and 11 columns. So over here, you see we have 36 over here. Actually, you have a zero in the beginning. So in total, you have 37 rows. And as we saw earlier, we had 11 columns. So df.shape will show us the total number of rows and columns present in our data set. And then over here, we have used another function called df.isnull.sum. So what this function does is that it will display us if there are any null values present in our data set. So when it comes to null values, null values are nothing but empty values where we do not have any data in that particular row. So as of now, there are no empty or null values present in our data set. As you can see over here we have displayed all the column names, and over here is the number of null values, which is 0. So 0 indicates that there are no null values in this data set for now. And the next function we have used is df.info. So this df.info function shows us two things. One is the presence of null values, and in order to detect if there are any null values, what you do is that you match the total number of entries over here with these values. So if we have similar values over here, as you can see we have 37 here and 37 all over in these particular columns. That means there are no null values present in this particular column names. But let's say you have 37 entries over here and you just have 30 values over here. That means that 6 entries are missing in that particular column. So whenever you have matching values, it means that there are no null values. And the other thing that df.info displays us is that it will display us the type of data present in that particular column. So wherever we have integer values, let's say here we have serial number. This is of integer type, and then we have state name over here, which is of object type. So it will display as int for this particular column, which is serial number, and it will display as object type for state name. Let us go ahead and check for state name. Let us go ahead and check. And as you can see over here, serial number is of integer type, and then state name is of object type. And sometimes you can also find decimal values in these particular columns. For now, there are no decimal values. So decimal values are indicated by float. So this is what df.info does. It will display us the data types and the presence of null values. But in order to get a clear picture of the presence of null value, it is best to use the df.isnull.sum, as it will display the total number of missing values in that particular column. All right. And if there are any null values, it will be indicated by a number. Let's say we have 20 over here. That means that 20 missing values belong to that particular column. So let us go ahead and use the other function over here, which is the df.describe function. So when it comes to describe function, describe function works for only numerical columns. So wherever we have numerical columns, this function will only display those columns over here. As you can see over here, we have a column called as serial number, and then we have state name. All right. But when you check it over here, you'll see that that state name particular column is missing from this uh, uh, data frame over here. And as you can see, we have all the numeric values over here. So what the df.describe function will do is that it will display us all the descriptive statistics of our data, like mean, standard deviation, minimum and maximum values. All right. As you can see over here in this particular column, serial number, the mean of this column is over here, which is 319. All right. And it will also display us the minimum and maximum values. So over here, you can see that the minimum value present in this particular column, serial number, is 1, and the maximum value in this particular column is displayed over here, which is 11,111. All right. And then it will also display as the standard deviation. As you can see over here, the standard deviation is 1823 over here. All right. And then same thing for the other columns as well. This is the active column, where active column is the total number of active COVID-19 cases. So the minimum value over here is 0. And then again, this is our standard deviation. And then over here, our maximum value in this particular column is 2,22,526. All right. And when it comes to other columns, so wherever we have numeric values, This describe function will display its descriptive statistics. All right. And then in order to, the other thing that we can do to understand our data is to display the keys so that we can have a clear picture of all the column names. So in order to display column names, I've used df.keys over here, and this will display all the column names, like we have serial number, state name, active, positive. So when you have a lot of columns present in your data set, then you can use these two functions over here which do the same thing. They will display you all the column names, which will help you to use all the column names as and when required. So you can basically double click and copy that particular column name, and you don't have to again scroll to the data frame. So this is a very handy function. We have used df.keys over here, and same thing. The other way is to use df.columns. So they both do the same thing. And then we have used another function which is the df.anyunique. So what this function does is that, as you can see over here, the anyunique function is used to count distinct observations over requested access. So it will basically it will return us the series with number of distinct observations. So over here in the serial number column, we have 37 distinct observations. And as you can see over here, every column has 37 distinct observations. And then what we have done is we have used the df.tail. So there are two things to keep in mind over here. One is the tail. So tail will display as the bottom column names. So as you can see, these are all the column names in the end. And when we use df.head, it will display as the top five, like the first five column names. So these are the last five as we have used this tail. And we can add a value over here. Like if we add a number, let's say 10, then it will display as the last 10 columns. I mean, it will display as the last 10 rows. And and for now, when we don't give any particular value over, it will display as the last five or top five rows. As you can see over here, there is one extra column over here, which has no state name. So what we have done is that, so basically these are the total of all these columns. So active columns total is as follows over here, which is 2,22,526 and so on. All right. So for now, we don't need this column. So what we do is that we'll have to use ilog function. So ilog function will help us to use only a particular section of our data frame. As you can see over here, we have set the data frame where the data frame is locked only till the 36th row. So as I told earlier, the column index starts from 0. So we have given this alloc function, and now our data set will end over here, which is the West Bengal. So we'll cut the data set till here, as we don't have any state name in the last row. And as you can see over here, now this is our resulting data frame where our last row has West Bengal, and we have like successfully removed the last row which had the total. So the next thing that we have done over here is that we have used another way to create totals. So what we have done is we have used this sum function. So the sum function will return us the total of that particular mentioned column name. So as you can see here, we have used the df of active column name and used the sum, and this displayed as the total number of active cases, the total number of COVID-19 active cases, which is 2,22,526. And in a similar way, we have done the same thing for positive column. And as you can see over here, the total number of positive cases are 1,04,66,595. And then the same thing has been done for the cured column. We have used the sum function And as you can see over here, the total number of cured cases in India are 1,92,909. All right, and then we have the total number of COVID-19 deaths. And as you can see over here, the total number of deaths in India are 1,51,160. And then the same thing has been repeated for other column names, which include the new active column, and which the new active column has around 2,16,558 new active cases. And then we have the new positive column. Again, we have 1 crore 4,79,179 new positive cases. And as you can see over here, the total number of new cured cases are 1 crore 1,11,294. And then in the end, we have the total the total number of new death cases, which are 1,51,327. And now let us go ahead and do our data visualization. So far, we have done the data understanding, and we have used functions like keys, columns, and unique describe function, and we have used the head, tail, info. So basically, we have a idea about how this data is all about, and we have this basic info. But in order to get an in-depth information, now we have to use data visualization techniques in order to see how this data is uh, spread spread. And in order to understand this data, we have visualized our first visualization over here is the scatter plot. So in order to display all the scatter plots, we use a function called as the sns.pair plot. So what this pair plot will show us is that it will display us the scatter plots of the entire data. So as you can see over here on the x-axis, the x-axis is the left bottom scatter plot over here has serial number on its x-axis, and then on the y we have new death. All right, so what this scatter plot shows over here is that this is the serial number on the x-axis, but when it comes to the other scatter plot, here the x-axis will change. Before it was serial number, then the second bottommost scatter plot over here has active on its x-axis. And then the third scatter plot has the positive column on its x-axis. But one thing to be kept in mind is that on the y-axis, this y-axis is going to remain same for all these scatter plots over here. Only the x-axis will change. And this is how the particular scatter plot looks like. And let us go over here. Here we have new cured on the y-axis, and on the x we have serial number. Again over here, on the x-axis will change, but on the y-axis will be new cured for all the scatter plots. So this is how a scatter plot will show us all the scatter plots present in the data. And the next thing that we have done over here is that we have created a subset of the entire data set. And what we have done is that we have calculated the sum of the data frame, and we have stored all those values in the cases underscore df. And this is how the subset data set looks like. This is our cases underscore df, which is our subset. And now we have the totals of all the columns. We have the serial numbers total, we have the state names, we have the active cases total. So among these column names, there are a few column names that have to be removed as they are not numeric in nature. So we have removed the state name, and in order to remove a column, we use a function called as the drop function, and we have dropped the serial number as it is not of any use. We have dropped the state name, and then we have also dropped the state code, as the data that we are looking for are in these columns: active, positive, queued, death, new active, new positive, new queued, and new death. Remaining three columns are of no use. And then we have used in place equal to true. And now this is how our subset dataset looks like. So now we are only remaining with the column names and their total. So what we have done is that we have created a pie chart, and as you can see over here, in order to create a pie chart, what we have done over here in this code is that we have taken these numbers. So in this particular pie chart, we have only taken the active, positive, cured and death columns, and we have taken the values. We just copy pasted these values over here. So the first four values are as follows over here. We have created a list and stored all those numeric values in that particular list. So, but when you run the data, the values over here will change as the data will be updated every day. So these numbers are going to change. So keep that in mind. And over here, the next thing that we have done here is that we have given our label names as well. So over here, we have 2,22,526 is active. So this is our number and this is our label for that particular number over here. And then we have used the positive, cured and death label names. And then the next thing that you can see over here is we have given an explode. So what this does is that when we give 0, this particular section is going to stay closer to the other section of the pie chart. But in the end, you can see that the last section over here has an explode value which is 1.5. What will happen is that this part over here, so this basically belong to here. By giving the explode as 1.5, we have shifted this particular piece over here in order to get a depth perception of this value. And as you can see, these are the color names. And then we have given the figure size as 13,8. The next thing that we can see over here is that over here we have given the data as my data. So whatever was stored in this my data, so these are those values. And then these are the labels, my labels. Right over here, you can see we have used auto PCT. So what this really does is that it will enable us to display the percentage value using Python string format. All right. And then we have given a tilt angle over here. And then this is the shadow equal to true. So as you can see over here, we have a shadow and the colors. So whatever are stored in these my colors are, these are those colors. And then we have these explode values that we gave earlier. And as you can see over here, there are 50% positive cases and the total number of queued cases are 48.2, and then these are the active cases which is 1.1, and these are the total number of death percentage which is like 0.74. And so this is our pie chart over here. The next pie chart that we have visualized are the new values. So wherever we have these new active, new positive, new queued and new dead. So we did the same thing as this pie chart. We have taken these values, and then we have taken these labels, and then as you can see, these are the new values over here, new case values. And as you can see, these are those labels: new active, new positive, new queued and new dead. And then again, the same thing has been repeated. We have used the explode. We have given the explode numbers, and these are the colors again. Over here, this is the figure size, and we have taken the data labels, and this will display the percentage. And this is the start angle which is 15, and shadow is true as you can see over here. And then we have given the explode values, and then we use plt.show to visualize our data set over here. And again, when it comes to this visualization, around 50% there are new positive cases which are 50%, and then the new cured cases are 48.2%. Then new active percentage is 1, and then we have new death percentage which is again 0.74. And moving on to the next visualization, we have taken all the values. So these are all the values like the active, positive, cured and death, then new active, new positive, new cured and new death. So these are all the values again, and these are all the labels. And then in the end we gave explode. So wherever we give this 1.5, so that particular section is gonna move out of that particular pie chart. So if we give the value as 0, then you won't have this we'll have a normal round pie chart, and then these are the colors. And as you can see, same thing has been repeated again. These are the label names, data, and then this is the percentage. This will display the percentage, then shadow equal to true. And as you can see over here, now the total number of positive cases is 25%. The total number of cured percentage is 24.1. And then over here we have death and new active, which is 0.4 and 0.5. And then the new positive cases are 25%, and the new cured percentage is 24.1. And over here the active percentage is 0.5, and new death is 0.4. And let us go ahead and move on to our next visualizations, which are nothing but bar plots. So over here, what we have done is that we have used RC params, and we have given a figure size which is 13,8. As you can see over here, this is our bar plot. We have plotted a bar plot, and in order to plot this bar plot, we have taken the state name on the x-axis, and we have taken the total number of active cases on the y-axis. And in order to get a clear picture, what we have done is that we have used sort values. And so basically we have arranged our bar plots in an ascending order, and which will give us a clear picture. And we can clearly see over here that the highest number of active cases are in the state of Kerala, followed by Maharashtra, followed by Uttar Pradesh and Karnataka, and so on. And in the end, we have the lowest number of active cases in the state of Tripura, Arunachal Pradesh, Mizoram, Nagaland. So over here, you can see that our bar plots are arranged in an ascending order. And when we arrange our bar plots in an ascending order, then we get a clear picture of which state is high and which state is low, and we can easily compare the states or any other columns. And the next visualization over here is again a bar plot, but now we have compared the state name on x-axis, and on the y-axis this time we have taken the death column instead of the active case. So over here the state names are going to stay same on the x-axis, and again we have used these sort values over here. And as you can see, we have arranged these bar plots in an ascending order. And again over here you can see that the highest number of death cases are in the state of Maharashtra, followed by Tamil Nadu, Karnataka, Delhi, West Bengal. And again the lowest number of death cases are in the state of Arunachal Pradesh, Andaman Nicobar Islands. And so this will give you a clear picture like which state has the highest number of death cases or not. And then we have displayed the column names again in order to visualize other bar plots. You don't have to again load the data frame, just displaying the column names, and then we can directly copy paste these column names over here. And over here we have taken the state name on x-axis and the active cases on the y-axis over here. Here we have used another color, and as you can see over here, when you do not use the group by function, this is how our bar plot looks like. So this is the difference between these bar plots, and then we have these the bar plots which are not arranged in any order. And as you can see over here the total number of active cases are again in Kerala and followed by Maharashtra. And then let us go ahead with our next visualization over here. We have taken the state name on the x-axis, and then we have taken the positive cases on the y-axis over here, and the color remains the same, and this is our figure size. And over here you will see that we have used x-sticks rotation equal to 90. So what this line will do is that it will rotate our labels on the x-axis, or else they are going to be overlapping, and it will create a confusion like which label is what. So when you use rotation equal to 90 on x-sticks, it will rotate the labels, allowing us to see the label names. And as you can see over here, the total number of positive cases are high in Maharashtra, followed by Karnataka, and then Andhra Pradesh. All right. And then the lowest amount of positive cases are in Chandigarh, Arunachal Pradesh, Dadra and Nagar Haveli, and Daman and Diu. So this is how the bar plot looks like when we take state name on X and positive cases on the Y. Then over here we have another bar graph over here where we have taken the state name on X axis and the queued cases on the Y. And as you can see again, Maharashtra is on top. A lot of patients have been cured from the COVID-19 in Maharashtra, followed by Karnataka and then Tamil Nadu. And wherever there are high number of cases, we see that a lot of people have cured. And wherever we had low amount of cases, the same thing can be seen over here again when it comes to their curing that particular disease. And as you can see over here, Maharashtra is on top when it comes to the total number of deaths, followed by Karnataka, and then we have Tamil Nadu. And the next visualization over here has the state name again on the x-axis and the new active cases on the y-axis. So previous visualizations had death, active, positive. Here these visualizations have the new active, new death columns. And over here you can see that the new cases or new active cases are higher in the state of Kerala and Maharashtra. And the lowest number of new active cases are in the Lakshadweep Islands, Meghalaya, Mizoram, Nagaland, Puducherry, Sikkim, Tripura. And let us move ahead with the next visualization over here. We have the state name again on the x-axis and new positive. And again we have Maharashtra on top, followed by Karnataka, Tamil Nadu, and so on. And let us go ahead with the next visualization over here. We have the state name on the x-axis again and the new cured on the y. And as you can see, Maharashtra is on top when it comes to cured cases as well as new cured cases. And then we have Karnataka after Maharashtra, and after Karnataka we have Tamil Nadu, and the lowest amount of new cured cases are again in the in the Lakshadweep Islands, state of Mizoram, Manipur, Meghalaya, Ladakh, and then we have Daman and Diu. And over here, this is our next visualization. Here it can be seen that Maharashtra has the highest new death rates in India, followed by Karnataka, and then again we have Tamil Nadu, followed by West Bengal, Uttar Pradesh, Andhra Pradesh, and again we have used the column names. We have displayed all the column names over here, and here we have dropped the serial number and state code from the original data set, and this is not a subset data set, so we have basically edited our original data frame. We have dropped the serial number and state code over here, and over here you can see that we have warnings. In order to remove these warnings, what you can do is that you can import warnings and then type warnings.filter warnings and ignore in a bracket. So whenever you get these warnings, the import will remove such warnings and directly run that particular code. And over here, as you can see, the resulting data frame over here has the state name and these all. And over here, we don't see the serial number and the state code anymore. And what we have done here is that basically this is our index over here. So we have these numeric values 0, 1, 2, 3. So this is our index. Using the set underscore index function, what we have done is that we have set the state name as the index. So when you see over here, when you run the data frame, these state names have become our index values over here. And what we have done is that we have created a stacked bar plot. And as you can see over here, we have a key and each color represents a particular column name over here, which is Blue stands for active, orange for positive. And over here we have used the stacked bar plot. And as you can see over here, when it comes to Maharashtra, the number of positive cases is higher than any other state. And when it comes to the number of cured cases, again Maharashtra is on the top. And then we have the brown color over here, which is the new positive cases. And again Maharashtra is on top. And then when it comes to the new cured cases, again as you can see, Maharashtra is on top. And so wherever we have new cases, or the higher the number of cases in a particular state, we can say that there are higher active, positive, cured, and death cases in that particular state. As you can see, the total number of cases are higher in Maharashtra. That's the reason why we have more positive cases, more cured cases, more uh, new active cases, and so on, compared to other states over here. And this is what a stacked bar plot does. And then what we have done is that again we have created a bar plot. This time here we can see that we have taken cured and death. So basically we are comparing these two column names in order to see the total number of cured cases as well as the total number of death cases over here. And as you can see, in the state of Maharashtra, the number of cured is high and the number of death is low. That means more number of patients are being cured of that particular disease, and very few number of people are dying because of that particular disease over here. And we can also see that in the state of Assam, Bihar, there are high number of cases which are cured, and there are no death cases in these particular states. And so compared to all the death rates caused by COVID-19, we can say that the death rates are high in the state of Maharashtra when we compare it with the other states' death rates. And at the same time, we have to also admit that the total number of cured cases are high in Maharashtra compared to any other state. The next visualization over here, we have compared the total number of positive cases and the total number of death cases. And as you can see over here, again, Maharashtra has a high number of positive cases compared to any other state. At the same time, Maharashtra also has the highest number of death rates compared to any other state. And states like Odisha, Mizoram, Meghalaya, Manipur have very less death rates compared to any other state. And then over here in the next visualization, we have taken the death cases and the total number of cured cases. And as you can see, again, same thing can be seen where Maharashtra has the highest cured cases, and compared to any other state, Maharashtra again has the highest cases of death reported because of COVID-19. And then in the next visualization over here, this is our final visualization where we have taken the total number of active cases and death cases and we have compared them both. And over here we can say that the higher number of active cases are in the state of Kerala, followed by Maharashtra. And again, the highest number of death cases are not in Kerala. So over here we can see that there is a change where highest active cases are in the state of Kerala, but the total number of death cases caused by COVID-19 in Kerala is comparatively low. And again, we have Maharashtra on top over here. Maharashtra again has the highest number of active cases and highest number of death cases. So over here, Kerala has high active cases but low death ratio over here. And again, states like Mizoram, Meghalaya have very less new active cases and very less total death cases caused by COVID-19. So that's it for this video. So what we have done over here is that we have loaded the data set. We have imported our libraries first, then loaded the data set from this particular website. And then we did some basic understanding of the data using few functions like the info describe sum is null dot sum. And then next thing that we did over here is that we took the sum of all these columns using the sum function. And then after understanding our data, to get an in-depth understanding, we perform some visualization techniques, starting with the pair plot, which displayed us all the scatter plots. And then we created a subset data frame, and we created a pie chart giving the total values and the labels which belong to those values. And after that, we started visualizing our bar plots. And that's it for this video. Hope you like this video. And until then, have a good day. And I will see